How's everyone doing?
Good.
Okay. So my name's Chris Mitchell. I'm a programmer analyst at E&J Gallo Winery. I've been there for about 3 years now. We are a heavy Lambda shop, so I thought I'd put a talk on today about Lambda. So I was curious, how many people here have used Lambda before? Cool. So about how many are you guys using it in production, just playing around with it, that kind of thing? Production use? Okay, cool. So my talk today kind of goes through like three layers of Lambda, I guess you could say. So kind of just an intro of what we're talking about today. What are some of the things you can do with versioning? We talk about layers, and then the final thing is local development, which I think is kind of funny because they do all this stuff to get Lambda in the cloud, and then the first thing I figured out how to do was bring it away from the cloud and develop locally because it's way easier. So before we get started, I guess, some prereqs. To do all the Lambda stuff, you do need an AWS account. I really recommend installing the AWS CLI if you're going to be using Lambda because it has everything that the dashboard can do, but it's more, to me, it feels like it's more at your fingertips. And then to do local development, you'll need the SAM environment installed. I kind of don't go into that because it's a little bit out of scope of this talk, but you'll get the gist of it when I'll do some demos in a bit. So what is Lambda, really? I mean, they say run code in the cloud, right? So what does that actually mean? So it's actually under the hood. It's running a Docker container using Amazon Linux. Forgive me if I misspeak about this part of it a little bit because this digs a little bit deep, and I've only done just to try to figure out like what it's doing. But so under the hood, it's just running a AWS SDK for JavaScript in a Docker container, basically. You get a Linux kernel, and out of the box you get JavaScript and Python. There's many more things you can do with it, PHP even nowadays. I've even heard people doing C. So basically, code in the cloud. So to get started, we'll visit the AWS dashboard and find Lambda. And then from there, it's just as easy as creating a new function. It's really easy to get started with it. I put roles here, though. Roles and permissions in anything AWS can get kind of hairy. But it's out of the box, it's pretty easy. You just select the default role and say, hey, let's just run some Lambda code. So from the dashboard, they split it up into a couple of nice sections. You get a designer section. You actually have a code editor in the cloud. I've always been kind of leery of code editors in the cloud. They're not very useful half the time, but this one's not too bad. It'll give you syntax highlighting, some simple autocomplete, things like that. From the dashboard, we can also set environment variables. We can adjust memory. We can tag our function, and there's a bunch more things that you can do from the dashboard. So from the dashboard, we can also test our functions, which basically means run the code. So we go to the dashboard, we create a test event, and then we run it, and then we can see the outputs right there on the dashboard in the console. So enough talk. Let's just do this. I figure might as well do live demo talk, right, instead of a bunch of slides. So I'm going to log into my AWS account here. One thing I should mention, my talk is pretty demo heavy, and the internet, I've had kind of problems with it. I'm tethered to my phone right now, and it seems to do okay. It was interesting, over the Wi-Fi, it wouldn't let me save anything in the dashboard. So I couldn't do code editing, but I could view everything. It just wouldn't let me save, and that's something to do with the Wi-Fi. I'm not really sure. So we're going to try it over the tethered phone. Everything looks a little small there, but we can get the gist of it. So from the console, I'm going to go to Lambda. And then so you can see I've got some functions already created here. I was kind of playing with this just to get started, but for demo purposes, we'll just create a new function. So you can use blueprints. There's also an app repository that's kind of fun. So some pre-built apps for you to get started with and whatnot, and blueprints. I usually just go from scratch because I have an idea in my head what I'm going to be trying to run. I've usually written it already locally. So I'll just author from scratch. I'll create a new function here. Earlier I was calling it video games. Because who doesn't want an API endpoint that returns video games, right? So here's your runtimes here, all the different runtimes you can do out of the box, Go, Java, all that kind of stuff. I usually stick with JavaScript because that's what I like to do. And here's the roles part. This is where you can define your roles for. So roles, just a quick like overview. Anything that needs to access your Lambda function or anything that your Lambda function needs to access, you have to apply a role to do that. So that's where the roles get kind of weird. There's just lots of different things you can do. But out of the box, easy, quick demo, you can just create a new role with basic permissions, and it'll let you run the code. That's what the role does. So we're going to create our function. Hopefully this doesn't take too terribly long over the Wi-Fi.
Excuse me.
Sure.
Do you think you could make that full screen and a bit larger?
Yeah, definitely. Good idea, thanks. Better?
Not by much.
Yeah.
There we go, that's what we're talking about.
Old eyes in the room.
Yeah, no problem. Cool. Yeah, if anyone has any questions along the way, I'm definitely, please let's talk about it before I keep rambling on. Otherwise, I'll just sit up here and talk the whole time. So definitely interrupt, ask questions, go through this together. I definitely like doing that. So here's the dashboard that I talked about. We have the designer view. So it created our video games function. We have a designer view. Here's where you can add triggers to kick off your Lambda function. Say, you have an API gateway, you have an Alexa skill that needs to talk to Lambda. This is where in the designer view you can wire all of that stuff together. And you have your input, and then you can actually define where your output goes to. So by default, it goes to CloudWatch. So you can view your logs of how your function ran through CloudWatch. Here's the code editor that I mentioned. So you can create, it's got just your basic code editor stuff here. I can, it says to do implement my function. So why don't we go ahead and write some code in there. So nice little editor there. It'll do some syntax highlighting and stuff. It's like, hey, I don't like that. So pretty cool to get started there. Here's where you set up environment variables. Environment variables is where AWS will inject these into your Lambda function. So you can do things like database connections, usernames, passwords, that kind of thing. They're not secure as they're just plain text right here on the page. So I wouldn't recommend doing anything production-ready database. There's other ways to inject into Lambda to do that. But for here, you can just, maybe you're in dev and you just need a quick database connection. So you can call, give it DB. And then let me in is always my favorite. Tags, you can tag your, tagging is great for organizing your functions. And then also, tags are kind of like roles. They can just keep going deep and whatever you want to use them for. So execution rule.
Purely for the UI of organizing your Lambda function.
Yeah, we use it to tag projects at work, even for billing. So you can run a bill and say, hey, give me all the Lambda functions that ran with this tag. How much did that cost? Yeah, cool stuff. And so here's where you define how much memory your Lambda function can get out of the box. It's 128. That's usually good. The timeout is 3 seconds. Sometimes it's pretty fast. For demo, if you're just doing the console log, no problem. If you're actually chugging away at something, sometimes it can do more. I think the maximum is 300 seconds. Or actually, I think they upped that. I think it's 15 minutes now. I don't know why you would need a Lambda function that would run 15 minutes, but if you're so inclined. Debugging, error handling, networking, there's just more and more. So the deeper you dig into Lambda, there's just a lot of stuff to do. So why don't we run our function here? So what we do is save it. Everything gets saved to the function. We're a little slow Wi-Fi. And then we're gonna test it. So what we can do is we can configure test events for Lambda to run. So test events are what data is coming into Lambda. Lambda needs to know what to do. So this quick hello world gets you started right here. Maybe this is where we can request our video games. So if I have a game, maybe God of War, and then I have another game. One game's probably good enough. So another nice feature here. It's I really like how AWS doesn't allow you to type bad code pretty much anywhere. So it'll lint your JSON for you. So if we create that test event, you do have to name it. And only letters and numbers. There we go. So now we have a test event. And so what this does is Lambda injects your test event, runs your code in JavaScript, and then we'll see our execution results here. So our hello from Lambda is what's returned, and then our console logs are down here. And so we wrote some code. I didn't show the actual test event stuff. So everything that gets passed into Lambda, it comes through an event object here. By default, this is the code that Lambda will write for you, and you do want that event object. So we'll just console log our event, and save it, and then test it again. So as you can see, pretty easy to just write some quick code to, run JavaScript. You don't have to install anything, do anything crazy. So now in my, I have my event right here, so God of War. And then if you wanted to get crazy, you could actually, like our test events can get really, because we're simulating like actual calls, actual Lambda events. They can all be injected in using that event. So it's easy to test it here. And that's pretty much the console. Any questions so far? Good? All right. I'm going to switch back to my
Is it
slides.
language agnostic?
Sorry?
Is this language agnostic? Like you can write any code in there?
Any code, yes. That's what they say. Out of the box, it'll do like Go, Python, JavaScript, Java, C#. And then if you, I haven't done it, but there's a way you can inject your own runtime libraries. So if I think you use Docker and you upload your your runtime like that, and then it'll run that Docker container for you.
And the test event is effectively always just sending a string, right? Because that's JSON, it sends as a string as the first argument, and you're having to parse it to JSON. Is that always the case from that little test text field that you have there?
It is always, it's JSON. So it's always passed in
Always
like
JSON.
this, yeah. So if I didn't have anything here, I guess you could just do that and it would just be an empty JSON. But it is always going to be JSON, so it's always going to be an object. So you can grab whatever from it right off the bat. Yes, sir.
Is there a node instance running behind that, or is it their own JavaScript?
It is Node. Yeah, it's Node. That's when you select the runtime library, when you create it. You can do Node 10, Node 8. I think they discontinued 6 now. And then they'll just keep adding them on. So under the hood, it is actually Node. It's not anything, AWS.
And can you run Express or node libraries?
Yeah, absolutely. So you would upload your code as a zip file. So, and this, I think it tells you here, right here. No, it doesn't tell you right here. But if your code has like node modules and you have a fairly large application, you would upload it as a zip file to Lambda, and then you lose the code editor online when you do that, but no one really wants to fully develop in the code editor anyway. So
Is there an API for pushing up to?
yeah, absolutely. The CLI that I talked about earlier, the AWS CLI, definitely install that. Like if you're going to do anything Lambda, I would install that right off the bat and do that.
Have you used Claudia? And if so, what's your opinion about that?
I haven't. What's up?
It's just a helper to like create node lambdas pretty quickly.
Gotcha. Yeah, I've seen a couple of those. I think they just released an official Visual Studio Code plugin that'll do that, and there's serverless framework and all that kind of stuff too.
Okay.
Yeah, I've mostly just done it myself through the console and through the CLI, but there's definitely a few tools out there that'll make this stuff easier to do once you start getting going with it.
Can you just point it to a Git repository? That would make sense.
That would make sense, and I believe you can, not through just the Lambda, but AWS has I think it's called code commit, and that's how it wires it up. I think it has to do with these triggers up here. I haven't done it personally, but I'm pretty sure you can do that with code commit. I mean, if I commit my code to Git and just appear in Lambda, that'd be perfect. That's actually maybe that'll be my next talk. Cool. So that's pretty much the console part, part one of the tour here. So I'm gonna go back to my slides here. Let's see. So Versioning is it's possible through the console. When you're testing and stuff, you just run code. They call it latest. Excuse me. Anything that's running in that console and anything that you save, it's considered latest code. But say I wanted to like tag it, like, hey, I'm done. I'm ready to go to ACC or production, and I don't want to change that code anymore. So we can create an alias, and we can create versions and all that kind of stuff. So they call it qualifiers. So we create a version, and then we tell Lambda what version we want to run, and we can give that an alias. So we can say prod code runs version 2, per se. I'll demo it in a second. It's a little weird, hard for me to explain, but basically what it does is it locks in function settings and function code, so we can run it as is without it being changed. Perfect for a production environment. And then you can also do roles to have it hands off. You know, only certain people can push these things to aliases and that kind of stuff. Everything has to be done. This last little note here is changes like memory and environment. All of those things get locked in when you create a version, which I think is pretty cool. So I have my latest, I'm playing with it, I'm adjusting memory, I'm adding environment variables and breaking things and all that kind of stuff. And then I get it right, I'm like, cool, lock it into a version, and then create an alias for it, and then we run that. So basically how you do it is we create our function code, we tag it as version 1, and then what we do is create 3 aliases from that version 1. So I like to do dev, ACC, and prod. You can do, it's an alias, you can name it whatever you like. And then you keep using latest for active development, and then when you're ready to go, you deploy version 2, and then you can point prod to version 2, and then ACC and dev will still be at version 1, and then that's how you can lock your code in and incrementally release. And then the qualifiers menu helps you figure out where aliases point. So again, with a demo, I think we'll set that up. This one's definitely easier to shine. When I first, I'm like, why? I don't understand. Let's just dig in. So back here on the console, again, you can do everything through CLI. So if you have like an automated deployment and whatnot, you can tag and release all through your CLI, like Jenkins or something. But it's quick and easy to do it right from the console as well. So what I want to do, so say I'm ready, this code is good to go, right? So we're doing something with the event. I'm saving it. All right, cool. I like this code. Like, hey, let's tag this one right here. So what we're going to do is publish a new version of it. And this is our first version. Good to go. Version description is just for your own, it's just a UI thing. So I publish it, and now my code is running up here. You see it's running on version 1. So then if I test this, it's running version 1. And then, like I mentioned, all this stuff down here is, I believe it won't even let me type here. It's locked in. I can see the code, but I can't do anything with it. I can't add environment variables. It's locked in. Here we go, version 1. So now I want to create an alias. So I want to say that my ACC code, ACC for users to test, and we're going to test that on version 1. So this is also a cool little option right here you can do. You can shift traffic to different versions based on weight. So I can say 10% of this goes to version 1 and the rest goes to version 2. I haven't played with that too much, especially not in production. It's a little weird, but that option is definitely there. So now I have an ACC alias, which now runs version 1, and you can see it's here, and then down here I'm on version 1. And so then if I went back to my video games function, now I'm back on latest code, and so this code that's here doesn't modify anything that I have under my qualifiers here. So ACC is used to test, it's at version 1, and it'll stay there. So now I can continue to write more code. And save that. And again, ACC is untouched. And now if I even wanted to publish a new version, so let's do dev testing. So now I have 2 versions of my code, and I have it. gives you a little preview right here. So I'm testing in 2. ACC is still pointed at 1. And then say, okay, now version 2. I think I'm good to go. I'm going to push that to my users now. So now we would go to our qualifier, our aliases here, and go to ACC. And I can change this to 2 and save it. And now ACC is pointed to version 2. 1 is obsolete. We don't care. I can still keep it around. You can delete it, anything like that. And so now this process over and over and over again, you can continue to roll forward. If I had production, I would do the same thing. I create 3 aliases, you know, that kind of thing. This is all again available to do through the CLI. So if you write some code, you know, hey, I commit to Git, pass all my tests, create a new version, point production to the new version, it would roll out automatically.
Is this how you handle your QA in the real world?
Yeah, exactly. Yeah, this was it was a lifesaver to be able to do this because latest is very scary. I don't like even having people run code against it in acceptance testing or anything like that. So version it, create an alias for it, and then it's locked in, and we never touch it. Cool.
So
Yes.
the latest version is the live one?
The other way around. The alias is the live one, and the latest is your ever-changing latest code set. Yep. Cool. So that's pretty much for it for aliases and that kind of thing. Any other questions there? Cool. All right. Let's go to our third option here. So next we have layers. Layers are fairly new in Lambda, I think within the year. So what layers allows us to do is, say you have a node module that you've written, or even something that you use all the time, a node library. I always use Salesforce for an example. There's a great Salesforce node module that we use across a lot of our functions. So instead of including that node module in every function that I release, say I have 10 functions that use this, I can just create a layer. It's most useful with NPM libraries. That's where I usually find myself using this. And then also anything custom that you can do too. You can do custom anything. It's basically a way to inject dependencies into your code without including them in every function that you write. The Salesforce NPM package that I mentioned. And then these are reusable across all Lambda functions. So at the root of Lambda, and I'll demo this in a second, is where you manage your layers. They have versioning. They get rolled out similar to the aliases in Lambda, and so then you can manage your layers across all of your functions. So basically, what you do is you set up your code locally. Npm install. This caveat got me big time. I spent like 3 hours trying to figure out why they weren't working originally. It has to be in this format here: the name of the layer. And then inside that is the name of a folder called node.js, node_js, and then your code. So if I have NPM modules, I have package JSON, index, that kind of thing. Yeah.
Does it have to be named NPM modules, not node modules?
This part, this
That little guy right there.
anything inside of this, this is your code, so it doesn't matter.
Oh, okay.
Yeah.
Oh,
So Lambda wants the name of your layer, and then it wants a Node.js folder, so it can find it. I'm pretty sure.
So when I npm install at package JSON level, of course, it'll give me node_modules, and that's cool, right? 'Cause
Oh.
it's my custom stuff.
I bet. Yeah. I was just typing slides. I bet it's good call. I should change that to alleviate confusion, right? But yeah, definitely. Anything in there, I could have called it, ABC123. It doesn't matter. It's injected into your code at that rate. So however you do your code. And so then you just zip up that directory, and then you upload it to Lambda. So basically, create a new layer, give it a name, description. Licensing is interesting. I believe you can share them across accounts. So if you want to license them or open source or however all that stuff works, and then you select a runtime for it. So you do have to tell Lambda that I am using a node layer. What's interesting is you can actually select up to 5 runtimes for a layer. I haven't really found a use case for that where I would need to use the same layer across, say, a C# function and a JavaScript function. But I guess if you have a JavaScript function that you need to kick off in C#, I guess that would be the use case. And then you attach it to your function, and then you just use your code like you normally would. It's a little, at first it's a little weird. Your question?
No.
Oh, sorry. Cool. Yeah, no problem. At first it's a little weird because you don't see the code. You just say, use module, and it's just magically there. But after a while, when you figure out the versioning and the layers, it makes it a whole lot easier. So I can demo it. This one is going to be a little bit weird because of the Wi-Fi. When I tried to upload my NPM 10 megs, sounds like that. But you could do simply as just an index.js if you wanted to upload it. But I wanted to just give a quick overview where that's at. At first, it took me a minute to find it because it's a global Lambda thing. So you have to go back to your Lambda home screen here, and here's your layers option over here. So you manage layers outside of the function is pretty much the takeaway here. Yeah, so I have my Salesforce layer that I created here. Say I had written a custom Salesforce object, and now any of my Lambda layers can use that.
So the way you reference that, is it just considered, so whatever Salesforce exports, right, as a name, how do you say import thing from?
Sure. So in Node or just in JavaScript, you would just require Salesforce. I can type it out, but Salesforce equals require your module name, just like you do normally in any other Node thing. You just assume that the Node modules folder exists underneath the hood.
Treat it just like it's that name, and it's that name specifically, so it'd be single, it'd be quotation marks Salesforce.
It's actually your object. So yeah, kind of confusing. So I can name this whatever I want right here, and then that's probably a great design pattern would be to name your object the same thing as what your layer is named, but it doesn't have to be. So in my object, if I called it, SF, in Node, that's how I would actually reference it. Yeah. I guess the pattern is with Node modules, right? The name of the module is the require statement too. So that's a great point. A good design pattern. Yeah. So to create a layer is pretty simple. You just name your layer. I had my Salesforce option, but maybe I have does anybody use Axios Node module? It's a great HTTP library. So perfect example. I use Axios in every one of my functions, right? So I create a layer here. I do npm install locally, and then I would upload it as a zip file here, and then create a layer for it. And then here's where you select your runtimes. I'm using Node. So I'm just going to skip the upload part, but that's basically, and then you create, and then it comes back here, and you would have your new layer. And then over here in your actual Lambda functions, so if I go to Lambda, over here in my functions, I think we were working on video games today. There's this little layer button right here, so if you click on this, it's nice to give you a little hint, like scroll down, there's layers. So I'd add a layer to my function, and here's my Salesforce layer. Here's where you can provide a layer version ARN. So you can do, this is how you can do cross-account layer inclusion. I haven't played with that too much. I've just pretty much uploaded my own, but I believe there's public. You can get public layers. So instead of everyone downloading Axios and uploading here, I'm pretty sure eventually it's going to be a thing where the maintainers just put it right into Lambda and you can use it. So I'm thinking ahead of myself. Anyways, here's my compatible layers Salesforce. Compatible layers is an interesting point. It does have to match runtimes, otherwise it won't show up here. That's another caveat. And it doesn't select any runtimes by default. It'll actually allow you to create a layer without a runtime. So be careful if you do to make sure you match up your runtimes. It's usually pretty simple because most people are writing JavaScript in Lambda, so you just always select JavaScript or whatever you're working on.
So you couldn't run like a Node 8 layer on for a Node 10?
You can't. It won't. You can select it as compatible, so 8 or 10, but you can, if I only say 10, then it won't let, and this is an 8 function, it won't let me attach the layer. Which is probably a good thing, because then you don't have cross, compatibility issues and that kind of thing. And then also fun with layers, you can do versioning. I wish I haven't seen aliases with this, so it's not as in-depth with qualifiers and whatnot that we talked about earlier, but at least I can version it. So if I roll out a new version, it doesn't work, it's easy enough to roll it back, that kind of thing. And so then I click attach or add, and now I have, sorry, yeah, go ahead.
It feels a little bit like a private NPM, just a little bit.
Absolutely, that's absolutely what it is.
Yeah.
Yeah. Like I said, I haven't really found a way to use or anything else outside of like NPM, unless you have like really massive applications that you're trying to run in, that you're including applications within applications and that kind of thing. For me, it's just upload NPM every time. So now my layers here, I click back here to get back to my actual Lambda code. And so like what we were talking about earlier, here in your JavaScript function, I would just say, SF equals require, and then that Salesforce pattern that we talked about there. And then in theory, I'm not going to test this because it won't work because I didn't actually upload it, but I could say, new SF here. Equals new SF. Just like you would in your regular, your node library. Cool, so that's pretty much layers. Any questions there? Good. Simple, but yet very powerful. So now we're going to talk about local Lambda. So after we did all this stuff in the cloud, let's actually develop locally and see what that looks like. So my pattern is develop locally, upload code, and then we run it in the cloud. It's good for all functions. Large, small, everything. This is really my go-to pattern is develop locally. Use CLI to put it into the cloud, and then it runs there. So how it works is you upload a zip file to S3, and then you load it from there. That's how I do it there. For time reasons, I didn't set up that other thing, but again, with that next talk, I'm thinking a code deployed in Lambda would be a great talk. We can call it Lambda version 2. And then, like I mentioned too, Lambda layers, you don't have to include NPM in your uploads, but you do have to have it locally, obviously, to run your code. So it uses AWS. I use AWS Serverless Application Model, SAM. It's a CLI tool. You do have to install it locally. It's pretty much just like installing any other CLI. You use Python or something like that, but again, with time, I'm not going to install it here. There's a lot of cool tips on the web to install it. Use it for local debugging, testing, and then I use VS Code for integrated debugger, so I can step through my code. That was when we first started using Lambda at work, we'd never had a way to step through code. We'd console log everywhere and then check the logs and see how it works. But with VS Code and SAM, I can actually pause, breakpoint, all that kind of stuff, and I can demo that too. And so the way it works locally is you create your test events as a JSON file, and then it's essentially the same thing as running it in the console. So you do have to install Docker as well. I forgot to mention that one too. But so you need Docker, AWS CLI, and SAM all running locally to be able to do it. The way it works is you create a template.yaml file, and it defines your functions. The template.yaml file is basically a YAML. There's a sample over here. It's a YAML rip that's probably really hard to see. Yeah. But basically it's a YAML representation of how your Lambda function runs. So it's a serverless function. It has a runtime. You can inject environment variables. It's like the console in a YAML file. So you define everything that you want to do there, and when you run, it will use this YAML file to configure your Lambda function. And so then when you run it, you want to attach VS Code to be able to debug. So you create a debug configuration in VS Code, and then a launch. This gets a little bit complicated, I apologize, but I'll demo it and hopefully it'll all make sense. You create a launch.json file, and then when you run the Lambda code in the debug mode, VS Code will use that launch configuration to connect it together, and then you'll have your debugging. And this is a quick example of what the really hard to see text looks like. But it's basically a JSON file with your configuration of how to connect VS Code to your template.yaml. And so the way, in the end, you would end up with a test event. You need a test event. That's that same test event that we did in the console, where you, but locally it's just a JSON file, and it should must match what your test JSON looks like in the console too. Layers are also available too. You would, in that template.yaml file that I showed, you would use the ARN, the resource ID of the layer, and it will actually download the layer from AWS and inject it into your code locally. So I guess in that sense, you don't even have to have NPM modules installed locally if you wanted to just run this directly through SAM. So bringing it all together, SAM runs a template.yaml, and then VS Code runs debug config, which listens to the YAML file, and then it'll inject your test event, and you magically run Lambda locally. So you do use SAM. So SAM is the CLI tool that you trigger with it. And you can run it with or without debugging. If you want to just run your function locally and see what happens, you don't even have to debug. You can just run it. The debugging part is kind of like the bonus for me, because then I can open it up with VS Code and walk through it and debug it, that kind of thing. There's a quick little command there to see how to do it. SAM local invoke is the actual command, and then the name of your function, and then the flag E for your test event, and then the optional debug port 5858 is how you would connect it to VS Code. So with debugging, the debug flag, I think that's the typo there. Anyways, you include the debug flag at 5858. And then in VS Code, you would just debug it like you would any other application that you're running locally. Breakpoints will stop code. You can step in, you step over code. It's really handy to actually, watch your code run. So I can give a quick demo of that. In the interest of time, I've kind of, because you do have to install Docker and CLI and all that other kind of stuff. I'll make this bigger so we can see it. So I have my Lambda demo function here. I have my test events. I have my demo JSON. So here's my games that I was talking about earlier. So this would technically match your event that you create in the console. This is a great place where you can just throw it at any data that you would like. And so what I'm going to do is, from this Lambda demo function, from here, I need my template YAML. I think one thing that my slides mentioned and I didn't mention is testing Lambda functions. You can test multiple Lambda functions locally. So the structure is a template.yaml file here, which is, let me minimize this stuff. So say I had 5 demo functions. You would put the template.yaml at the root, and then you would define your functions in here for each one that you would do, and then you give it a code URI. So you can essentially test multiple functions with one YAML file. So we can go ahead and do that here. So we do SAM local invoke, and and my event is whatever one I'm going to run. And then debug 5858. If this all works out, it will be magical. So what it did is it launched a Docker container using my runtime of Node.js. I don't know if I can make that even bigger for you. Kinda. Because this is really interesting here. I know this is kind of just a quick overview. If you go home and play with it, it's actually a lot of fun because you can watch your Lambda functions run. So it launched your Node.js Docker container. and it launched a debugger session on port 5858, and then it stopped. Said, I'm waiting for a debugger now. So in code, if you go to your debugger console here, and you connect it, your debugger attaches, and you can actually step through your code. I set a breakpoint here, and so it stopped here, and then I have my whole debug console, all this kind of stuff here, so I can check out my event, and it actually shows all the data here. And then step over code, step through code, rerun code, so you're full on debugger there. Cool. So that's pretty much running Lambda locally. I know it's like this much stuff to do condensed into this little guy here, but there's a lot of tutorials on the web there. I've actually written a couple of them for myself too. But once you start playing with it, it's very powerful and it's pretty fun. So any questions about local debugging? Good. See if I
We're
can
looking at Visual Studio.
Visual Studio Code. I believe you could connect any debugger to it, anything that'll listen on a debugging port. Yeah, but basically just a debugger. Yeah, I use Visual Studio Code to do that. Cool. And so that's about it there. There's lots more stuff that you can do with Lambda too. You can do, they have those, I mentioned them earlier, the pre-built applications ready to go. So it's fun to just throw those in your Lambda console and run them, see what they do, look at the code. You can do a lot of monitoring with it with CloudWatch. You can do like logging and things like that. And then you can also do, you can use CloudWatch to trigger Lambda events and all that kind of stuff. And then the code deploy stuff is definitely going to be my next talk because I've mentioned it many times now. So the way and just in a quick closing, you create triggers to use Lambda functions, and these triggers exist in almost every other AWS service. So Alexa, CloudWatch, API Gateway, pretty much everything can trigger Lambda, and those triggers are the events that we've seen earlier there. And that's how you kind of wire it all together. Cool. And thanks. Looks like I'm right at 45 minutes. So 5 minutes question and answer session. Yes, sir.
Do you trigger this, or have you triggered the Lambda functions through Jenkins?
You would need to trigger AWS to trigger it. So Jenkins can trigger something in AWS that would trigger Lambda.
Okay.
Yeah, so it has to have like a, typically it's API Gateway, that's what we use mostly. So we have like an endpoint, / video games, expose that to the internet or expose it to Jenkins, and then Jenkins would call it.
Okay.
Yeah, I don't know of a way to trigger, I don't think you can. You have to go through an AWS service to get it to trigger it.
Have you looked at serverless framework?
I have not. We had already, I take that back. We did look at it. I just haven't dug in really deep. One of the things that turned us off really quick was, and this could be wrong because I didn't take enough, right? But it forced us to change the way we organized our code because we already had all of this stuff, pretty much up and running, API Gateway, the whole thing ready to go. And then serverless said, oh, you have to actually deploy everything like this. And I said, I can't really use that, and so I stopped.
Yeah.
Have you used it?
Yeah, but came to it completely green.
Okay.
So some like very isolated little uses.
Yeah.
So it's not that what you're describing is really a problem for me. I think there might be a way around what you're talking about.
Sure,
but
sure.
What you're doing is working.
Right, but I am absolutely looking to do more, automated deploy, CLI tools, all that kind of stuff, and I think serverless frameworks are probably the way to go.
I think you can pass like a -- package, and it will. That's I think what you have to use when you're using a like Circle CI or something like that.
Gotcha. So it'll work with us if we just figure out how to do it, basically. Yeah. Maybe.
Yeah, I'd say it would.
Yeah,
Maybe.
but definitely something to look into. Yeah, I know it's a big name in the field and whatnot.
Yeah.
So yeah, definitely something to look into.
What are some of the biggest issues you've had with Lambda? I've heard other people talk about latency.
Latency, yeah. So they're called cold starts. So under the hood, I believe it's trying to launch a Docker container. So say you haven't called your function in forever, it's trying to spin up a Docker container so it can actually run the code. And as you can imagine, that takes 5-10 seconds or something like that. And on a web request, that's not going to work. So the way we handle it, and there's probably better ways to do that, is we have a CloudWatch for some of our more important user-facing functions. We have a CloudWatch rule that runs every minute to say, hey, ping me, to make sure there's never a cold start for those specific ones. Yeah, there might be a better way to do that because I absolutely hate doing, you're getting charged for that too. That's one thing I didn't mention too is cost for Lambda is extremely cheap. I should include a whole nother slide about that. You don't have to run servers. They charge you it's ridiculously cheap, 0.001 cents per millisecond run or something like that. So we run all of our functions through Lambda, and our bill just dropped to the floor instead of running EC2 servers. It was great. So definitely another presentation you could do about cost. Cost savings in Lambda is huge. And for all this stuff that I do, testing and whatnot, I've never seen a bill on my AWS account more than $5. And that's one time because I forgot to turn off the light cell server. So.
On the cold start thing, there's a really good resource. There's a blog post. If you just search visualizing cold starts.
Visualizing cold starts? Okay, cool.
Yeah, there's a really good post on just explaining that and comparing the different cloud providers and
Yeah, it's definitely
a visual of how much because for a lot of stuff it doesn't matter.
Right, because you're just it's like a processing, right? It's just gonna turn on and process. But if it's a user-facing function, that's where we were really worried about it. Yeah.
And AWS has gotten really good at limiting that problem. But
Okay.
one problem I found is if you have to put your Lambda function inside of a virtual private connection.
Right.
That's when it's 10, 15 seconds sometimes.
Yeah, so we don't run any of our Lambda functions inside of VPS at all because of that. Yeah, unless it's I guess it depends. I shouldn't say any. None of the web-facing ones do because it's just too slow.
Yeah.
If you're doing database connections and processing data and whatnot from your databases, then I would suggest putting it in a VPS for security and whatnot. But for user-facing functions, definitely not. I thought of another issue that we had too is the timeout part. Now that they've upped it to 15 minutes, we really haven't had a problem. But we were definitely trying to do too much in the beginning with 5-minute timeouts, trying to process data through Lambda, which was great because it was cheap, so we could move databases or whatever you got to do. But we did run into that 5-minute timeout a lot, and then you put API gateway in front of it and your triggers for a trigger, and it's only 30 seconds. So we had to architect around API gateway, but then 5 minutes. So the timing issue can definitely be something to think about too. If you're really trying to process something for 15 minutes, I suggest EC2 or something with more compute power.
So if you're kind of adopting modular, simple, focused function,
microservice, right? Yeah, sure.
How does that translate in serverless? Do you just have function, tons of functions and sprinkled around everywhere? And how do you
that's basically how we do it. So a function is a microservice in an e-commerce world, we have cart, we have user, and so they're functions. They are sometimes quite large, and so it does kind of break the microservices pattern. There's ways with that event that you can say, this event is add to cart, this event is remove from cart, so on and so on. So we try to keep our one function to a microservice. So basically a function is a microservice. Cool.
I had a question about layers. It might help with the. I've never used layers.
Okay.
So if I understand it correctly, you're saying it's for sharing code.
Sharing code.
Across multiple Lambda functions.
Yep.
Does that help you on a price level at scale? I mean, I've never had a big bill for AWS either, but at scale, I imagine that might help.
Sure. Yeah. So that could absolutely be a pattern. So say you have a cart, but you need to get a user. So typically you would just call another Lambda function to get the user as a microservice, but you could essentially include your code, your user code as a dependency to your cart object, sure. If you actually, it's kind of does break the rules, but it would work, I guess, at the same time, because then you get into, your cart object knows about your user object or does it not, and so then the microservices part, but that's a whole just different discussion, but it's technically possible, yeah.
Well, so if you're pulling in a library, for example, in a layer that you use in almost all of your functions, like your example, does that lower the amount of cost?
No, it's just adding to your code. So your code base is this, and now it's this.
I see.
Yeah, and it doesn't execute anything in layers. It just adds it as a dependency.
Okay.
Yeah.
So you don't have to add it locally. Okay.
Yeah, exactly.
Thank you.
All right, thanks guys.